Hello, today I'm going to be talking about the fundamental theorem of calculus. Here's a quick overview of what I will be talking about. First, I will go over a few important definitions and theorems. Specifically, I will go over what an antiderivative is, and I will go over the chain rule. Then I will go over the fundamental theorem of calculus, which has two parts. The first part deals with establishing a relationship between derivatives and integrals, while the second part deals with evaluating integrals and using antiderivatives. Additionally, I will go over one practice problem for each part of the theorem. Here we have the definition of an antiderivative. A function F is an antiderivative of f if F prime of x equals f of x for all x in the domain. An antiderivative is the function that results from integration. We also have the chain rule. Let the functions f and g be differentiable. Then the composition of functions g of f is differentiable, and the derivative of g of f of x is equal to g prime of f of x multiplied by f prime of x. The chain rule allows us to easily calculate the derivative of a composition of functions. On to the first part of the fundamental theorem of calculus. Let D be a subset of the real numbers, and let A and B be contained in D. If the function f from D to the real numbers is continuous over the closed interval from A to B, and the function F is defined by F of x equals the integral from A to x of f of t dt, then F prime of x equals f of x over the interval from A to B. This theorem establishes a relationship between derivatives and integrals, showing that it is possible to find the original function using the derivative function. Let's do a practice problem now. Let F of x equal the integral from 2 to 3x squared of t cubed dt. Find F prime of x. If we want to find F prime, then we need to take the derivative of both sides. Since we are taking the derivative of a composite function, we need to apply the chain rule. The derivative of the integral is equal to the integrated function t cubed at the upper bound 3x squared multiplied by the derivative of the upper bound. The derivative of 3x squared is 6x. This simplifies to 162x to the 7th. On to the second part of the fundamental theorem of calculus. Let D be a subset of the real numbers, and let A and B be contained in D. If the function f from D to the real numbers is continuous over the closed interval from A to B, and F of x is the antiderivative of f of x, then the integral from A to B of f of x dx is equal to the antiderivative of b minus the antiderivative of a. Let's do a practice problem. Use the fundamental theorem of calculus to evaluate the integral from 1 to 4 of the square root of x dx. The first thing we need to do is find the antiderivative of the square root of x. This is 2/3 x to the 3/2. We will evaluate it from 1 to 4. Next, we plug in the upper and lower bounds for x. The antiderivative at the upper bound is 16/3, and the antiderivative at the lower bound is 2/3. This simplifies to 14/3. Here are a few references that I use while making my video. Feel free to check them out if you want to learn more about the fundamental theorem of calculus. Thanks for watching.